Good day, everyone. My name is Mlungisi Nkosi once again. Welcome to our YouTube channel. And so we are still busy with the functions. And today we're going to look at, the quadratic function, or in this case, the parabola. If you haven't subscribed to our YouTube channel, welcome. Please just consider being part of the family and just subscribe. And for those of you who might need assistance with either mathematics or physical science, of course, you can get in touch with us. And our email address is info@mlungisinkosi.co.za. All right, so we are first going to look at the quadratic function. Okay, so in this case, this is where we've got the highest power of x being 2. Okay, so the standard formula of a parabola would be y is equals to ax squared plus bx plus c. Now, several things that we are supposed to look at when it comes to the parabola. When the value of a is greater than 0, okay, so meaning a is positive, then we know that the type of graph that we are supposed to expect is a smiling graph. Okay, so it's a parabola that is shaped in this way. Okay, we call it concave, right? So in this case, it's concave up. So in this case, if our value of a is less than 0, meaning that your a value here in this equation is negative, then of course we've got what we call a sad parabola. Just keep that in mind. So this one tells us we've got a positive, and this one tells us we've got a negative. Okay, now I'm going to just show you a few things about a parabola, because this is not the only way in which it can be expressed. However, with each different way, there are different if you may call it advantages and disadvantages. Okay, but let me show you the first one. In this standard form, the advantage of having the standard form in this particular way is that if you look at, okay, I'm just going to take a different color. So if you look at the c value, the c value in this case tells you what is the y-intercept. So in this particular case, the advantage of having the standard form of a parabola in this manner is that you already would know what the y-intercept is. Just keep that in mind, okay? Right, now let's go to the second way in which parabolas can be expressed, okay? The second one is we can express them as y is equal to a into x minus p squared plus q. Now, please, I want you to listen carefully. In this way, when we express a parabola in this way, usually we take the standard equation or the standard form that I just shown you just now, and what we'll do is we just complete the square. I'm hoping that someday I'll be able to make an entire lesson on just how to, the 5 ways of solving quadratic equations. And one of the ways of solving quadratic equations is to complete the square, right? So now what would be the advantage? The advantage here, let me take a different color again. So now you've got the values of p and q. Now what would p be? Now please, I want you to listen carefully. So it means that in this way, the advantage is that we now have the turning point. You see, there goes my spelling. So that would be the turning point. So we would know what the turning point is when we've got the parabola given to us in this way. Now, what would be the value of our turning point? Note very carefully. So the value of our turning point would be, or rather the coordinates, I should say, of the turning point would be P and Q. All right. So let me just make an example. Suppose you've got a parabola that's minus x minus 2 squared plus 4. So immediately, when you look at this graph, you would already know what would be the turning point in this particular case. The coordinates of the turning point would be, now please, I want you to note, do you see that minus p became positive p here? So whatever the value you have inside the bracket would change sign. So if I've got a minus 2 there, it means that my x value of the turning point would be positive 2. So if it was a positive 2, then you change it to a negative 2. And what's the y value? You see we had positive q there, and we also have positive q here. So q does not change sign. So it would be 2 and 4. Okay, just so that I just emphasize that again. So suppose we've got y is equals to 3 into x plus 1, okay, squared. Now let's just change it a little bit. Let's say minus 5. Okay, so in that case, what would be your turning point? So your turning point, once again, would be, right, so it means that it would be minus 1 and minus 5. Can you see that the q value does not change sign? However, the p value does. Okay, right. So this is the second way in which we can express a quadratic equation. Okay, and then we've got another way, which is the third way. Okay, all right, I didn't label the others. So this would be y is equals to a into x minus m, x minus n. Okay, so this would be another way. So in this case, the advantage is that it would immediately be able to determine the x-intercept. So in this particular way, what we would have are the x-intercepts. Okay, so sometimes we do call them the roots of the equation, right? So in this case, what would be our value? What would be our x-intercept? For the parabola, we have two x-intercepts, okay? And in this case, your x-intercept would be at m and 0, right? Note that that's the x-intercept. It means that's where y is equal to 0. And then another one would be at n and 0. Note that they change sign once again. So let me just make an example quickly. So if we are given, let's say x is equals to, let's say just for argument's sake, that's x minus 1 and x plus 3. Okay, so it would simply mean that we would know the x-intercepts here very quickly. We would just equate that to 0, and what we would have as our x-intercept is, you'd equate this to 0 and you'd be able to solve for x, and in that case we would have our x-intercept being 1 and 0, as well as minus 3 and 0. Note that they change sign. Okay, so we're going to be looking at a couple of examples, but I'm just going to quickly revisit a concept as we go along, which is factorization. Again, that is quite one of the core, most important things to learn in mathematics, factorization. In that case, I'll show you just how to navigate your way around factorization. Of course, as I did say, I will make a lesson just simply on the ways of solving quadratic equations. Okay, so without any further ado, let's do this. Let's take an example. Okay, all right, now let's look at example 1. They say draw the graph of y is equal to x squared plus 3x plus 2. So what we're going to do with the parabola is that we are going to, number one, look at, okay, so we're going to look at the y-intercept, okay, and we are going to look at the x-intercept, and I'll show you how we are going to therefore look at the turning point. If you don't mind, I'm just going to abbreviate it as TP. So in this particular case, we're trying to draw this graph, and we want the y-intercept, the x-intercept, and the turning point, and thereafter we can draw the graph. Okay, right, so let's start with the first one. So let's look for the y-intercept. Now, if you remember what I said, if we are given the equation in this particular format, right, we said what's the advantage? The advantage is that we would already immediately know what the y-intercept is. Okay, where that comes from is that, remember what happens at the y-intercept. Okay, at the y-intercept, this is where x is equal to 0. So just remember that y-intercept, we know that x is equal to 0. So it means that I can substitute for I can substitute 0 wherever I see x into my equation. So this would be y is equal to 0 squared plus 3 times 0 plus 2 in my original equation. And what am I left with? I'm left with 2. So it means that at my y-intercept, I have 2. See now, I'm making an error right at the beginning. So in this case, I would have where x is equal to 0 and y is equal to 2. So this would be the coordinate of my y-intercept. Okay, right. And then the second thing that we wanted to do is to now find the x-intercept. So we're going to take the original equation and say, okay, let's find the x-intercept. So in this case, I'm just simply going to say, right, so the second thing we're doing is find the x-intercept. And this is where I want us to spend a little bit of time so that I can show you just a few things about factorization. Okay, so it means here, what happens at the x-intercept? We know that this is where y is equal to 0. So we are taking our original equation, x squared plus 3x plus 2 is equal to 0. Now, ladies and gents, of course, many tend to struggle with factorization. And as I continue, I'm going to show you different ways in which you're going to factorize and just make it easier. That's the purpose of this channel, is to try and break things down, make them as simple as possible. Okay, right. So what you do when you factorize, now please, I want you to listen carefully. When you factorize, I am going to simply, now the value of a, meaning the coefficient of x squared, is 1. So in that case, I can open up two brackets, right? We can open up our brackets, make them equal to 0. So what that does is that when the coefficient of x squared is 1, that's simply going to be x and x. Why? Because x multiplied by x will give me x squared, right? Now listen to the question I'm going to ask. Now, first of all, what are the factors of 2? Now note, I'm going to do this in a different color. What are the factors of 2 such that when I add them, look at this. I said, what are the factors of what? Of 2, such that when I add them. So in this case, the sign of your constant term, which is positive, tells you that whatever factors you are going to use, you're going to have to add those factors, listen carefully, to get. You're going to add those factors in order to obtain the middle term. Okay? So now my question was, what are the factors of 2 such that when I add them, they give me 3? What are the factors of 2? The factors of 2, it's 1 and 2, right? So if you think about the factors of 2, that's 1 and 2. So in this case, when I add 1 and 2, does it give me 3? Absolutely, it does, right? So in this case, I'm going to have 2 and 1 in there, okay? So now this means I want to find out, okay, what is the sign inside of my bracket? And again, please listen carefully. All I'm simply going to say is, if the sign of your constant term, which is this one here, okay, the one that I'm circling in blue, if that sign is positive, then it tells you that your brackets or the signs inside the brackets are the same. Please listen. So it tells me that the signs inside the bracket are the same. And where do I get the sign of the bracket? I get it from the middle term. Okay, so I've got a positive sign here in my constant term next to the 2. So it tells me that the signs inside the bracket are the same. So it could either be negative or positive, but which sign would be inside the bracket? I'd go to the middle term, and I see in the middle term, I've got a plus there. So signs are the same, and it means that in both instances, I've got a plus and a plus. Okay, right. So then I would say, well, you know, this would mean that x would be equal to -2, or it means that x is equal to -1. So what that simply means is that when I look at my x-intercepts, right, my x-intercepts are going to be -2 and 0. And I'm going to have -1 and 0. Okay, so now we've got our x-intercept and our y-intercept. I hope that you understood the part about factorization, right? And then the third thing that I'm going to do is now we're going to look for the turning point. Okay, when we've done calculus, obviously we'll come back to this, but how do I now get the turning point before we get to the part where we do calculus? So when you find the x value of the turning point, please, I want you to listen carefully. So the x value of the turning point will always be minus b divided by 2a. Now remember, which one is b in our equation? Remember the middle, the coefficient of the middle term, that's b, and the coefficient of the of the x squared term, that's a. So my a is equals to 1, my b is equal to 3, and my c value is 2. Okay, so in this case, I know that my a is 1, my b is 2, my b value is 3 rather. So now I'm going to say, well, that's minus, let's substitute, our b value is positive 3 divided by 2 times my a value is 1. So in this case, what do we end up with? We end up with minus 3 over 2. Now, ladies and gents, you have to be very careful. So now how do I get the y value of my turning point? All I simply do to get the y value of the turning point, I am going to substitute the x value of the turning point that I've just obtained into the original equation. Okay, so I'm going to say, remember our original equation, let me write it as it was. So that's going to be x squared, okay, plus 3x plus 2. So in this case, when I substitute, remember I said I substitute my x value of the turning point, so I'm going to say that's minus 3 over 2 squared plus 3 into negative 3 over 2 plus 2. And so that you can get to your final answer. Okay, I'm just going to get my calculator quickly. All right, and we try and obtain that. Okay, so we've got 3 over 2. That's negative. Almost left out that part. So negative 3 over 2 squared. Okay, plus 3 into 3 over 2. And the last one plus 2, and my y value, oh no, I almost made a mistake there again. So that's negative 3 over 2, and that means my y value of my turning point would be negative 1 over 4. So I get that value to be negative 1 over 4. So that means what is my turning point in that case? It means that my turning point would actually be at -3/2 and -1/4. All right, now let's try and draw that graph. All right, remembering all that we obtained. Okay, let me try to use a ruler so that it would actually be much neater. Okay, so there it is. Okay, please, I'm not going to try and make it as accurate. Okay, so there's our graph. Okay, so I'm just going to use a different color. Okay, let's first of all plot all the points that we have, right? So we knew, okay, going back, we knew that the graph is going to cut the x-axis at -2 and -1. Okay, so we know the graph is going to cut the x-axis at -2 and -1. Let's put -1 there. Okay, I know that's not very accurate. Okay, so this is -1 over there. That's going to be -2. And of course, you'll have 1 and 2 on the other side. Okay, so this is our x-intercept. That's going to be our y, not x-intercept, rather, x-axis, as well as our y-axis. So in this case, now I know this is where we're going to cut in terms of x. Okay, but what about y-intercept? We said our y-intercept, if you remember that, okay, this was at 2, you remember. Okay, so we said this represents our y-intercept. Okay, we said at 0 and 2, this is where x is equal to 0. Okay, so x is equal to 0 and y is equal to 2. So let's put it round about there. Okay, right, if you don't mind, I'm just going to try by all means to, in fact, maybe I should take that point a little bit higher. Okay, so that we don't have a strange looking graph. Okay, and then our turning point, we said this is -3/2, so -3/2. If you remember, 3/2 is 1.5. So in this case, that's definitely in between those two. Okay, so -3/2, so that should be there. -3/2 and at -1/4. Okay, so if you don't mind, I'm just going to put that value there, -1/4. Let's put it round about there. Okay, and please remember, I'm not drawing this graph to be accurate, so I'm just trying to illustrate. So in this case, all I'm simply going to do, this is the point. Okay, I forgot to put the 2 there. Okay, so this is where 2 is. All right, so now let's try by all means to try and draw that graph, okay, for ourselves. All I simply do is connect those points. So usually what I like doing is that when I get to that turning point, remember our a value was positive, so it tells us it's a smiling graph. Okay, so I know that I'm expecting it to turn just like that. Okay, right, so I'm going to try and connect there, and I'm going to try to connect also on the other side. Okay, hope you don't mind the ugliness of my graph. Okay, so this is what our parabola would more or less look like. I should have actually just drawn it more to the right so that we could see it clearly. So this is what our parabola would look like. Now, ladies and gents, I just want to mention something else called, when we talk about the turning point, another word that we use for the turning point, and I know this is not going to look really nice because it's my graph is not really very accurate. So we call the turning point also the axis of symmetry. Okay, and the reason for that is that if you kind of look at it in that sense, our axis of symmetry kind of cut the graph into two equal parts. Okay, so we call them the axis of symmetry. So meaning, if I go in that direction, going that way, and also going that way, it would be the same distance. If you think about it here, on the x-axis, remember to move from towards the right, this is from -3/2 to 1. This is -3/2 to 2. Okay, it would be the same distance. Well, if my graph, actually it was supposed to look more like that. So in a sense, your graph is cut into two equal parts at the turning point. So we call those the axis of symmetry. All right, just keep that in mind for the future. Another thing is, then we can talk about the domain. Okay, actually I didn't talk about that in our lesson for the straight line graph. So the domain for the parabola. Now, what is a domain? A domain is essentially, where does your graph exist in the x-axis, okay, on the x line. So in this case, what is the domain for a parabola? It would go from -infinity. If you think about it, if you go all the way to infinity, as you go that way, the graph still exists. It goes up and up and up and up all the way. And if you go towards your right, your graph exists all the way up until there. So it means that it exists all the way to infinity as you go in that direction. Okay, right. So now what we're simply saying is that the domain for a parabola, well, we say x is an element of real numbers, right? Or if you really wanted to be pedantic about it, we can say x is an element of -infinity to infinity. Okay, and of course we exclude those because we don't know where infinity is, so there's no specific point where there is infinity. So in this case, then we talk about the range. Now please, I want you to listen carefully. When we talk about the range for this graph, we know that the range, in this case, where does the graph exist on the y axis? Okay, so in this case, I want you to please note, our graph has a turning point, okay, at -1/4, which is there. In fact, I should have labeled that turning point there. So that turning point would be at -3/2. Okay, so that's -3/2 and -1/4. That's our turning point. So the graph essentially does not exist below that point. Okay, so it exists from -1/4 in the y, right all the way up until infinity. So our range in this case would be y is an element of, okay, -1/4. Okay, sorry about that. It exists there. Okay, so in this case it would be -1/4. We are including, now when we use square brackets, we mean that we are including it because it does exist over there up until positive infinity, and we are going to exclude that. Alternatively, how you can express that is that you can say y is less than infinity, but it's greater than -1/4. Okay, greater or equal to, I should say, because we are including it there, and that would be your range. Okay, right, so that is how the cookie crumbles. Right, I know that's been kind of long. Perhaps what I'll do is that I'll reserve some of the examples that I wanted to make because I don't want the video to be too long. Okay, lest you sleep. Ooh. Okay, so what I'll do is that we'll do some more examples in the next video, but I want us to take just another example so that we solidify our concept. Okay, so let's look at our second example. So example number 2. So they say the diagram shows the graph of f of x, that's minus 2 into x plus 1 squared plus 8. They say C is the turning point, so there's our C value over there. Okay, and point E is the mirror image of the y-intercept of f. Right, now they say determine the length of AB. Now, if you notice there, when we're looking for the length of AB, which is that line, that yellow line over there, okay? So in order for us to obtain that, we would have to find out what are the coordinates of our graph, meaning that we need to find the x values of our x-intercept, okay? So now, deliberately, I've given you the equation in that format over there, okay? Just to remind us what we said. So in that format, what do we know? We already know the turning point. You know, I'm not answering any question at the moment, just reminding you. So we already know what the turning point is. And our turning point is essentially -1 and 8. Can you see that? So in this case, it would mean that this point C over here, so I'm just populating just what I know. This point C over there is already known to us. It's -1 and 8. And it makes sense. Our A value again is negative. So it's telling us that it's a said parabola. There's that A value over there. It's -2. So now, how do we find the value or the length of AB? So we said whenever you find the x-intercept, what do we do? Y has to be equal to 0, right? So what I'm going to do is take the original equation. Okay, so we know that y is equal to -2 into x plus 1 squared plus 8, and make that equal to 0 in order for us to find our x-intercept. So now we've got -2 into x plus 1. I just want to write it a little bit more neatly. Plus 8 is equals to 0. So let's try and solve for that. So I'm going to take 8 to the other side. Okay, so I've got -2 into x plus 1 squared, which is equal to -8. And what we are simply going to do is divide both sides by -2. So I'm going to divide by -2, divide by -2. And the reason I want to do that is so that this will cancel with that. And in this particular case, on the left-hand side, what am I left with? I'm left with x plus 1 all squared, okay, is equal to, now if I take negative, divide by negative, that would be a positive. 8 divided by 2, that would give us 4, okay? So now please keep in mind, now what I'm going to do is take the square root on both sides, okay? So I'm taking the square root on both sides, but when you take the square root on both sides, please remember that you end up with plus or minus on the right-hand side, okay? Keep that in mind for the future, right? When you take the square root, you're supposed to have, or any, even root for that matter, you know? And when it's odd, we don't need to do this, but when it's an even root, you always need to say plus minus. So in this case, what happens? It means that the square root would cancel the square, right? We're taking the square root in that case. So what are you left with? It's x plus 1 on this side. But on the right-hand side, you've got plus or minus. The square root of 4 is 2, okay? So, of course, we're going to have two roots. In this case, x plus 1 is equals to positive 2, or x plus 1 is equal to a negative 2. So therefore, x would be equal to, so if I take the 1 to the other side, that becomes 1, or x, if I take 1 to the other side, that's -3, right? So let's go back to our graph. So it means that our x-intercept, it's going to be 1 and 0, okay? and it's going to be negative 3 and 0. So look at this. So it means A would be our negative 3 and 0. It's on the negative side. Okay. And it means that our B, this is where we have 1 and 0. Okay. So in this particular case, we are looking for the distance. And please, I want you to listen carefully. When we're taking a vertical line, so meaning a line that is flat, it's not steep, right? When we take a vertical line, to find the distance, all we need to do is take the x value at B minus the x value at A. Why? Because the y value does not change, right? So AB, in this case, would be the x value at B, and I'm going to subtract the x value of A because they were looking for the distance. So my x value at B is 1, and I'm going to subtract the x value of A, which is negative 3, and it means that the distance AB would be equal to 4. Now please keep this in mind. If we're looking for a horizontal distance, okay, this is a horizontal distance, AB. If it was a vertical distance, vertical is in that way, horizontal is that way, right? So if we're looking for a vertical distance, in this case, meaning that if we're looking, let's say for, if we call that O there, okay? And you now want, let's say, OD for argument's sake, okay? So all you do is you take the difference of the y values. Okay, just keep that in mind for the future. It might come in handy. Right, so now we were looking for the distance AB, and then they say find the coordinates of C. Guess what? We've already found them already. Okay, so we said the coordinates of C. This is the advantage of having the standard form, or rather the format of the parabola given to us in this particular way, that we can get the turning point quite easily. So to answer number 2, there's our turning point over there. Okay, so the coordinates of C are negative 1 and 8. And then they say calculate or determine the length of DE, right? And remember what they said to us. They said that E is the mirror image of the y-intercept. So meaning, once again, what's happening here? It means that we are cutting the graph right into 2. So now they are saying that E is the mirror image, meaning that the distance from here in the middle going to D should be the same as the distance from here in the middle going to E. That's what it means when we say it's a mirror image. So now, will be the, you know, the y-intercept. So let's find the coordinates of D first. Okay, even though you know, they're not necessarily going to you know, matter that much, but I just want you to find it, just for me to show you how to find the coordinates of the y-intercept. So how would I find my y-intercept in this particular case? Right, so my y-intercept, this is where x is equal to 0. This is just for future reference, not that it's going to really matter for the sake of our answer. So our y-intercept in this case would be, so remember we said this is where x is equal to 0, so that's minus 2 into, now you remember our equation, it's x plus 1 squared. So where I see x, I'm going to put 0, so 0 plus 1 squared and plus 8. You remember that's our equation, plus 8, right? So this is plus 8. So if I take that, 1 squared, 0 plus 1 is 1, 1 squared is 1 still, times negative 2, that would be negative 2. So negative 2 plus 8 will give me 6. Okay, so it means that our y-intercept will be at the points 0 and positive 6. Okay, so this is our y-intercept. This I'm just doing for the sake of, just remembering that how to find the y-intercept. But we're not going to really need it to answer this question. Now, I want you to please note something. What is the distance from C, this point here, till D? Okay, note it is a vertical line. My distance between those two is 1. How do I know that? D is at 0, x is equal to 0. And this is the line of the turning point. This is the axis of symmetry. And where are our axes of symmetry? This is where x is equal to -1. Okay, so we know this is the line x is -1 right here. Okay, so now what is the distance between this point here? Let me just draw it in red. This point here and that point there, the distance between them is essentially 1 unit. Okay, sorry about that. So that's essentially 1 unit. So now we want the distance from E till D. Now what would be the distance from that axis of symmetry again till E? That would be another 1 unit. Okay, so in this case, if they are mirror images of each other, it means it's 1 unit going to the right, another unit going to the left. So it would simply mean that the distance ED or DE would essentially be equal to 2 units. Okay, so you can look at C as sort of the midpoint between E and D. So E is at 0, so we can also apply the midpoint theorem. Okay, so if I say for my midpoint, okay, I know it's going to be x at D plus x at E divided by 2. So my midpoint is at -1. Okay, so I'm looking now for the x value at E. So my x value at D is 0 plus x at E divided by 2. Okay, so you'll see how now we can just simply cross multiply there. Okay, so I would have -2 divided by -1, that would be -2, and 1 times xe, this would be x at E. So that means that the value at E is actually -2, the x value at, so the coordinates of E would be -2 and 6. I think we found the value to be 6 at that point there. All right, I hope you are still able to follow. I know there's a lot of gymnastics that I did there. So essentially, we know that the distance DE would be equal to 2 units. All right, so I hope that has been helpful, right? I want to leave it here because otherwise the lesson has been long enough, okay? I hope that this has been helpful. And we're still going to explore some more even on composite functions when it comes to the parabola, obviously mixing it with other functions as well. But otherwise, from me for now, I'm just going to leave this lesson here. And I'll see you guys again next time. Please, for those of you who haven't subscribed, please just click. Make sure that you're part of the family. I'll see you guys next time. Shap, shap.